All right, in this podcast, I'm going to show you guys how to find the exact value of an angle that may not be on the unit circle, so it's not a special angle, but it definitely could be split up using special angles on the unit circle. So for example here, we want to find the exact value of sine of 15 degrees. So once again, exact value means no decimals. So if you look at 15 degrees, obviously you're not going to find that on your unit circle because it's not considered a special angle. But you can rewrite it as in terms of two special angles, more specifically a sum or a difference. Now 15 degrees is pretty tiny, so I'm thinking that I'm going to take the difference, so I'm subtracting two special angles on the unit circle. So I'm looking at the unit circle here, and I can see that 45 degrees minus 30 degrees does give you 15 degrees. So that works out. You can also use 60 degrees minus 45 degrees. So it's all personal preference. It doesn't actually matter which difference you use, you will end up getting the same answer. Now let's say we choose 60 degrees minus 45 degrees. So I'm going to rewrite this expression as sine 60 degrees minus 45 degrees. I'm going to go ahead and split this up using my identities. So this is a difference identity more specifically for the sine. So I'm looking at this form of an identity to find an exact value here. Now if I rewrite this, remember my alpha is the first term, so that's our first angle, and that's my alpha, 60 degrees. And my beta will be the second angle, which will be 45 degrees. So let's go ahead and split this up. So we get the sine of 60 degrees times the cosine of beta, which is 45, minus the cosine of alpha, which is 60 degrees, times the sine of beta, which is 45 degrees. And you just go ahead and use your unit circle to evaluate each one. So the sine of 60 degrees, if I find 60, it's right there. We're looking at the y-coordinates. We have root 3 over 2 times the cosine of 45, which is just, we're looking at this coordinate right here, which is just root 2 over 2. Okay, then we're going to go ahead and subtract cos of 60, which is now the y-coordinate of, the x-coordinate of 60 degrees, which is 1/2. And then the sine of 45 degrees, which is the same thing as the cos, we get root 2 over 2. So I go ahead and simplify, and we'll end up getting here is, well, root 3 and root 2 can be combined as root 6, and we get 4 on the bottom. Minus 1 times the root 2 gives you root 2, and 4 on the bottom. All right, so that is one way you can express your answer, or you can express it as root 6 minus root 2 all over 4. That works out too. All right, and that's how you find the exact value of an angle that is on the unit circle.